Right, welcome back. Let's do question 7.1. An investment earns an interest of 7.5% per annum compounded quarterly. Calculate the effective annual interest rate of this investment. So what do we do with this? So we have to use the formula 1 plus I effective. This is the effective annual rate. And then I effective, that's the effective annual rate, then is equal to 1 plus I nominal, that's the nominal rate, then over m, then to the power m, right? And then we're looking for I effective. What is our m? Our m is going to be 4 because it says compounded quarterly. So where there's m, we're going to put 4 here. Then for I nominal, we put 0,075. So it's going to be 1 plus I effective is equal to 1 plus 0,075. This is 7.5% as what? As a decimal over 4, then to the power 4. Just that. And then I effective, we then subtract 1 from both sides of the equation. It's going to be 1 plus 0,075 over 4 to the power 4 minus 1. Then you can put this in the calculator. What do you get? I effective is equal to 0.07713586578. And then this as a percentage, we just multiply this by 100. So it means R is equal to 7.71%. This is now effective annually, meaning that is 7.71% per annum compounded annually. That's effective annually. Then 7.2, rhino poaching is a serious problem and has resulted in the black rhino becoming an endangered species. Statistics show that there were 60,000 black rhinos in 1970 and only 4,200 remained in 2011. Determine the annual rate of population decrease as a percentage over these 42 years if the rate is compound decay. Alright, our n here is going to be 42. Someone may be wondering why 42. Right, let me just give you a simple example. Let's say we have, it can be beginning of 2023 to the end of 2024. Right, how many years is this? From 23 to 24. This is beginning of 2023, then end of 2023, beginning of 2024, then end of 24. Do you see that is 2 years? Okay, so it's 2 years. But if you say 2024 minus 2023, you get 1. You see that? So same thing here. You can have your 42 years from these years, from 1970 to 2011. It's good that we are given the value of n. Okay, so we're going to use n as it is there. This is the compound decay. So we use the compound decay formula. A is equal to P1 minus I to the power n. At our A, this is our 4,200. It's compound decay. So A is smaller than P. And then P is equal to 60,000. And then N is equal to 42. Then you just substitute this into the formula. So it's 4,200 is equal to 60,000. And then 1 minus I to the power 42. We're finding what? We're finding the annual rate of population decrease. So we're finding I here. Then divide by 60,000 on both sides of the equation. 4,200 divided by 60,000 is equal to 1 minus I to the power 42. Right. And then what are we going to do? We have to find the 42nd root of both sides. So it's going to be 42nd root of 4,200 over 60,000. Then this is equal to 1 minus I. So what you can do, you can transpose this I to the left hand side. So it becomes I is equal to 1 remains on the right hand side, and then transpose this root the 42nd root of 4,200 over 60,000. Put this in the calculator. What you get, I is equal to 0.06113529181. So we can multiply this by 100 to convert it to a percentage. So I is equal to 6,14. This 3 will change and become 4 because of the 5 there. Then percent. That's the annual rate of population decrease. It decreases by 6,14% per annum. Alright, 7.3. Atom inherits 27,000, which he invests in a savings account. The interest is calculated at 5,4% compounded monthly for the full period. 3 years after he invested the initial amount, he withdraws X rands to make a down payment on a car. Calculate the value of X if he accumulated 17,614.76 cents in the savings account after 10 years. Right, the best thing to do here is to use the timeline. The interest rate does not change, so we have from the beginning up to the 10th year, the interest rate is just the same. This is 5,4% per annum compounded monthly. This is compounded monthly, right? And then what happens? At 3 years, X rands is withdrawn, so there's minus X here. At 3 years, okay, this is 3 years. We started by 27, let's start by this. So plus 27,000 here was invested. Then 3 years, X rands was what? Was withdrawn. And then how much does he have here? We have 17,614 rand 76 cents. So I prefer this method. There are many methods of doing this thing, but I prefer this. Right, I do the 27,000 on its own. It means it's going to be there for how many years? For the 10 years. And then I do this withdrawal on its own. It's going to be there with its interest for 7 years. Okay, because from here to there to the X is 3 years. Then from X to 17,714 rand 76 cents is 7 years, which is a total of 10 years. Right, so it means now if we have this, we're going to use this formula. A is equal to P1 plus I to the power N. We have our 17,614 rand 76, which is our accumulated amount, right, is equal to, let's start with 27,000, which is invested for the total of 10 years. So it's equal to 27,000 and then 1 plus 0,054 over 12 because it's compounded monthly, and then it's there for 10 years. So it's 10 times 12. Right, we're done with 27,000. Then this is a withdrawal. So it means you are subtracting. And then you subtract it with its interest. So it's going to be minus X, then 1 plus 0,054 over 12. And then it's there for what? For 7 years. 7 times 12. Okay, like that. Right? And then 17,614 rand 76 is equal to, this will give us 46,276,09397. Do not round off, use it as it is, then minus, and then this will give us 1,458,12599, then X. Okay, now we're just solving as what? We're just solving a linear equation here. Right? Subtract 46,276 rand, 0.09397 from both sides of the equation. If you say 17, if you say this amount minus this amount, you'll get negative 28,661,33397 is equal to negative 1,458,12599x, right? And then divide by this amount, both sides of the equation. You'll get that x is equal to 19 19,656 in comma 28073. Round off to 2 decimal places. This is 19,656 rand and 28 cents.